Hey guys, today we're going to be talking about how to use the formula sheet on the GED math test. So on the GED math test, there are several measurement problems, geometry, and even some algebra problems where you need to know the formula to figure out the answer, basically. And the formula sheet gives you the formula to do that. But sometimes we don't know how to use the formula sheet. Like, oh, there's the pi symbol. What in the world is that? And so I just wanted to make this video to kind of go over some of the basics of the formula sheet for the math test. And so, like I said, the formula sheet covers geometry and measurement and algebra. So if you're trying to get the perimeter, the volume, the surface area of something, or like dealing with algebra, let's say you need to get the slope of a line. Let's say you don't remember the Pythagorean theorem. So all of these are things on the formula sheet that we're going to be going over. So here's what the formula sheet looks like. And you can see that it is divided up into these different sections. So if you ever need to get the area of a shape, you're going to be looking at this section, the purple arrow. Now, so area is just the space inside of the shape, and we'll talk about that some more. Perimeter is the edges all added up. And so if you have to get the perimeter or the circumference of a shape, you're going to look in this section right here. Now, if you have a 3D shape, or a three-dimensional shape, and you have to get the surface area or the volume, you're going to be looking in this section. And so surface area is in this column, and then volume is in this column. So whenever you get to those kind of questions, make sure that you're looking in the right column, that you're looking at the right formula to solve the problem. And then in this section, we have data. So if you have to get the mean or the average of something, this tells you how to do that, or the median. It tells us how to do that. And then lastly, we have our algebra section. So this tells us how to get the slope of a line, how to use what the quadratic formula is, the Pythagorean theorem, simple interest, that kind of thing. And there's a lot of stuff on here, so we're not going to talk about every single one. I just want to try to get you acquainted with the formula sheet and give you some examples of problems where you would use that. So the first section on the formula sheet is area. So if you are trying to get the area, you're trying to find the inside, how much space is inside of that shape, basically. And here they list all the different ways that you would get the area of these different shapes. So for instance, if you have a square, notice it says S with an exponent 2. So the S stands for the side. So basically you take one side, let's say this is 2, and then this one's 2, and you square it, or you multiply it by itself. And in your calculator, to square something, you just hit 2. And then they call it the caret key, but I always call it the TP button. It looks like that. And then you hit 2 again, and then enter. Now to get a rectangle, it's almost exactly the same as a square. You take the length times the width. So if we have our rectangle, here's the length, here's the width, and we just multiply those together. Same thing if we have a parallelogram. And there's the formula for a triangle, a trapezoid, and a circle, so we're going to talk about all of these. So, like if I am trying to get the area of this square, so here's my square right here, I'm going to take the side, which is 3, and I'm going to square it, or multiply it times itself. So 3 times 3 gives me 9, so the area of our square is 9. Now let's say I have this shape. This shape is called a parallelogram. So anytime, if you ever see what looks like a rectangle or a square that's kind of been tilted on its side, that is called a parallelogram. And you'll see how it has this dotted line on the inside with the number 3. Anytime you see that dotted line, that is the height. So wherever it says h in the formula, that is where you put the height. Now, the lowercase letter b stands for base, or like the bottom of it. So our base in this case is 8. So all we're going to do is just plug these numbers into our formula. So our formula is A equals BH. So it's base times height. So our base is 8, our height is 3, and we just multiply those together. And we get 24. Now, this shape at the top is a rectangle. And so to get the area of a rectangle, we use length times width. So I have a 4 and a 7, so I'm just going to go 4 times 7. And when I do that, I get 28. So you just take the measurements that they give you and you plug them into the formula. So let's look at some more of these. Now, what if you get these kind of odd shapes? So we already talked about a parallelogram. Let's look at our triangle. So there's two different triangles you might run into. There's this right triangle where you have like a perfect corner, and then there's this kind of triangle where they will usually put a line down the middle, and they'll say, hey, this is 7. So let's say this is 12, the height of that line in the middle is 7, and then let's say this is 5, and this is 4. So the formula for a triangle is 1/2 base times height. So the base is just these bottom numbers here, and then in this case our height is 4, but if we don't have that straight edge like we do in this triangle, they'll draw that dotted line, and so on this one, our height is 7. So all we do is just plug these into our formula. So over here I go 1/2 times 12, so that's my base, times the height. And when I plug that into my calculator, I get 42. And then over here on the triangle on the right, I go 1/2 times 4 times 5. And when I do that, I get 10. So that's how we get the area of triangles. But let's look at these other two shapes. So this shape right here is our trapezoid. And so trapezoids, they show the height of them a lot like they do triangles. So here's our little right angle. Let's say that they have a 4 here. And then let's say that up top they say this is a 12, and then this one down here is a 17. So in the trapezoid formula, it says 1/2 times the height times B1 plus B2. So B1 and B2 are the bases of our trapezoid. So think of B1 and B2 as the flat lines, the lines that aren't slanted. So this one would be B1, and this one would be base 2, or B2. Now, it doesn't matter which one's base 1 and which one's base 2, as long as it's those perfectly flat lines. So now we're just going to plug that into our formula. So we go 1/2 times 4, which is our height, and then we go 12 plus 17. And you can put this exactly like it looks in your calculator, or you can do this step by step. Either one is perfectly acceptable. So when we put this in our calculator, we get 58. And so that is how we get the area of a trapezoid. And then the last one we're going to talk about, let me erase this, is our circle. So to get the area of a circle, it's just a little bit different than getting the area of these shapes that kind of have straight edges. So our formula is A equals pi r squared. Now, if you look back to the full formula sheet, notice how right here it says pi equals 3.14. So there is a pi button on your calculator, but never click it. It doesn't round it at like it should. You'll be off probably by several decimal points, so don't click the pi button on your calculator. Just don't do it. Pretend it doesn't exist, basically. So anytime you see that pi symbol, we just put 3.14 there instead. So we would take 3.14 for pi, and we're going to multiply it by r squared. And so r is just your radius. So the radius is halfway across your circle. Let's say I have a radius of 3. So we take 3 squared, and then we're going to multiply these together. So 3.14 times 3 squared is 28.26. So we get 28.26. Now, you would have units of measurement whenever you're doing these. So it would be like inches, feet. So whenever you get the area of something, it's in square, whatever units, square feet, square inches, square miles. Whenever you get the volume, it is in cubic units, cubic feet, cubic miles, cubic inches, that kind of thing. Oops. So next is perimeter. And so all perimeter is just the outer edges of the shape. Imagine that you are putting up a border in a room. That's what perimeter is. So honestly, there's all these fancy formulas for perimeter. Oops, sorry about that. But really, perimeter, you just add the sides together. If you have shapes with straight edges, triangles, rectangles, squares, trapezoids, all of that, all you do is add the sides together. So those are pretty self-explanatory. But what happens if you get a circle? Circles don't have flat edges. How in the world do we add those sides together? And so that is where we do what's called circumference. And so circumference, our formula is 2 pi r. Now r is just the radius of the circle, halfway across the circle. So here on this circle, my radius is 8. Now you'll notice I have this other circle below that where it has a line going all the way across. That is what is called the diameter. So for this circle all the way across, or the diameter, is 12. So you notice there's 2 formulas for the circumference of a circle. So we can use 2 pi r, or we can use pi times d, or times the diameter. Either one works. So if they give you the radius, use the problem that has the radius. If they give you the diameter, use the problem that has the diameter. So like for this circle, we would go 2 times 3.14. So remember, we never hit the pi button. Always put 3.14 times 8. And then for the one on the right, we would go 3.14 times 12. And so when we multiply these in our calculator, we get 50.24. And again, let's say it's in feet, so in feet. And then on the one on the right, you get 37.68. Again, we'll say it's feet. So that is circumference. So now let's look at surface area and volume. So surface area and volume is when we have 3D shapes. So anytime you have a 3-dimensional shape, you're either going to be getting the surface area or you're going to be getting the volume. And you'll notice on your formula sheet, they have it in 2 columns. So all of the formulas in the middle are surface area. And then all the ones on the right are volume. And so volume is all of the space inside of a 3D shape. Imagine like you're trying to fill up a shoebox. So the volume of the shoebox is all the space inside the shoebox. Now, surface area is all the space on the outer face of the shape. So a surface area, imagine that you are wrapping it with Christmas wrapping paper. So surface area is how much wrapping paper you need to wrap it. Volume is how much stuff you can use to fill up the shape. So when we get surface area or volume, here are our formulas. So just like with everything else, we take the numbers we know, we plug it into our formula sheet. So whenever we see the pi symbol, we put 3.14. Whenever you see the letter R, we put the radius. So remember, radius is halfway across the circle. When we see W, we put width. When we see H, we put height. And for L, we put the length. Oops. Now notice there's 2 sort of random ones at the bottom. It says P equals the perimeter of the base with area capital B. So anytime you see the capital B, you're getting the area of the base, of like the bottom shape of it. So like if you had a pyramid, I can't draw pyramids, but we'll say that's a pyramid. Let's say the perimeter has a length of 4 and a width of 2. Where it has that big capital letter B, we would go 2 times 4 to get the area of the base. So like if we were getting the surface area of a pyramid, that's what we do to get the capital letter B. But then if you get the letter P, it's the perimeter of the base. So let's say we're getting the surface area of the pyramid. We already have the capital letter B, but we need to know what P is. So that's the perimeter of it. So in this case, we would go 2 plus 2 plus 4 plus 4. So we would get 12. So the lowercase p is just the perimeter of all of it added, of all of the sides added together, of the base. And then lastly, there is a letter S. Now S, like if you notice right here, S is simply the slant. So in my very, very bad drawing of a pyramid, the slant is like this part. It is the side that slants inward on the pyramid. So sorry I can't draw pyramids very well, but hopefully you get the picture with that. Now I just want to go over some word problems and show you basically how we would use the formula sheet and how we would solve these. Now there's several. I'm not going to go over all of the ones, but we'll go over at least one per slide. So for instance, number 1 says Joseph likes to walk his dog around the park each evening. The rectangular park is 300 yards long and 140 yards wide. How far do Joseph and his dog walk each evening if they make 2 trips around the park? Now, this says that they walk around the park. They aren't filling in the space of the park. They're not walking every single inch of the park. They're walking around it on the edge. So that means that we're going to be dealing with perimeter. And remember, perimeter, all we do is just add our sides together. So it says that our rectangular park is 300 yards long, 140 wide. And it says that they make this trip twice. So we need to remember to multiply our answer by 2. So what's our equation? So our equation for the perimeter is 2L plus 2W. So 2 times length plus 2 times the width, or we can just add all the sides together. So I'm going to add 140 plus 140 plus 300 plus 300. And when I do that, I get 880, But again, he's walking this twice. He's taking 2 trips. So I need to remember to multiply that by 2. So when we do that, it's 1760 yards. So always remember to include your units, or they could count your answer as wrong. So make sure that you are using the units. Now on number 2, it says a family of 4 ordered a 20-inch round pizza on Friday night. There were no leftovers, and each person ate 2 equal-sized slices. To the nearest tenth, how many square inches of pizza did each person eat? So we're trying to get how much pizza there was. So that is area. But this one's a little bit different because we have to get the area of a circle. So remember, to get the area of a circle, it is pi r squared. And so r is our radius, or halfway across the circle. Now, this says it's a 20-inch round pizza. So that means all the way across it's 20 inches. So that means our diameter is 20. But they don't want to know all the way across. They want to know the radius, which is halfway across. So if it's 20 all the way across, how much is it halfway? 10. So now we're just going to take the radius, and we are going to plug that into our formula. So remember, for pi, we put 3.14, and we're going to multiply it by 10 squared. So when we do that, we get 314. Excuse me. So there's 314 of, the whole pizza. So a family of 4 ordered this pizza. There weren't any leftovers. Each person ate 2 equal-sized slices. To the nearest tenth, how many square inches of pizza did each person eat? So we have to divide this by 4. So 4 people, each of them got the same amount of pizza. So we're going to divide that by 4, and we get 78.5. So that is how much pizza they got. All right, let's look at this one. A booth at an arts and crafts fair sells popcorn in a cone-shaped plastic bags. Each large bag has a 6.5-inch diameter and is 15 inches tall. To the nearest square inch, what is the surface area of each bag? So, and it says, hint, the top of the cone bag isn't covered, so you don't need to include that in its area. So to get the surface area of a cone, our formula is surface area pi rs plus pi r squared. Now, this part of the formula, this pi r squared, that is the same as the formula to get the area of a circle. So think of a cone. The circle part of the cone is the top part. Now, it says the top of the bag isn't covered, so we don't even need this part. We're just going to be focusing on this section of the formula. And so keep an eye out for questions like that. So, for pi, we put 3.14. And it says our diameter is 6.5. So, we don't want the diameter, we want the radius, which is half of that. So 6.5 divided by 2 is 3.25, and then times s, so times that slant, or that height. And it says that it is 15 inches tall, so we're going to put that in for the s. And when we do that, we get 153. It says to the nearest square inch, so just 153. Now let's look at number 2 on here. Lou works with Cruz. Actually, let's look at number 1. Michelle is moving into her first apartment. She rents a cargo trailer that's 8 feet long and 5 feet wide. However, her kayak is 15 feet long, and she's not sure if it'll fit in the trailer at a diagonal. Use the Pythagorean theorem to determine if Michelle can carry her kayak in the trailer. So the Pythagorean theorem is when we take a right triangle, and let's look, what does our formula sheet say? A squared plus b squared equals c squared. So this side is a, this side's b, and the side that's across from the perfect corner is always c. And so if we are, and our formula is a squared plus b squared equals c squared. So if we're plugging this into our formula sheet, the trailer is 8 feet long and 5 feet wide. So 8 squared plus 5 squared equals c squared. So we need to figure out if this is enough space for her kayak. So in your calculator, you just put 8 squared plus 5 squared and hit enter, and we get 89. So c squared equals 89. Now, we might think that we're done, but we don't have c by itself. We have to do the opposite, of c squared. And the opposite of it is the square root symbol. So we got to get the square root of 89. And when we do that, we get 9.433, blah, 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 blah. So, the kayak is 15 feet long. She's only got 9 feet of space. So no, her kayak is not going to fit. She doesn't have enough space in that trailer. Alright, let's look at number 3. You want to make a rectangular concrete step outside your front door. you need to know how many bags of concrete mix to buy. The space measures 4.5 by 3 feet by 3 feet by 0.5 foot. Each bag of concrete mix makes about 0.45 cubic feet of concrete. How many bags will you need to purchase? So this is one that's another two-stepper. So first, we got to get the volume. And so the volume of a rectangular prism is just length times width times height. And they tell us all those measurements with the 4.5 feet by 3 by half of a foot. So we're just going to multiply these together. And when we do that, we get 6.75. Now, it says that each bag of concrete mix makes 45 cubic feet. How many bags will we need? So what we're going to do, we're going to take 6.75 and divide it by 0.45. And so when we do that, we get 15. So how many bags will they need? They need 15. Okay, let's look at number 5. It's the end of the summer, and Deandra is draining her circular pool to the nearest hundredth of a cubic foot. How much water will she pump out of the pool if it has 4.5 feet of water and is 24 feet in diameter? So we are trying to figure out what the area, or basically the volume of this pool. So it's a circular pool. Now, if it is a circular pool, it is basically a cylinder. So a cylinder is like a can shape. I can't draw, but you get the idea. So it says that it is 4.5 feet of water, so that's how deep it is. And its diameter is 24. And so we want to figure out how much water there is total, so what the volume is. So we're just going to plug that into our formula for a cylinder. So we put 3.14 for pi. And they want radius squared, but our diameter is 24, so what's half of that? What's our radius? 12 squared. And then we're going to multiply it by our height, which is 4.5. So when we multiply all of this together in our calculator, we get 2,034.72. Now, it didn't ask us, to the nearest hundredth. So, yeah, 2,034.72 cubic feet. So, we would write it like feet with the 3. So, I am about to run out of time with this, but I'm going to put the rest of these as a self-check in the Google Classroom. So, watch this video, do the self-check in the Google Classroom, make sure that you understood how to use the formula sheet and what we covered today. And if you have any questions, be sure to email us, to message us, get in touch with us, and look for some more updates in the Google Classroom, and look for updates on our Facebook pages as well. And I hope you guys have a great day, and I hope you have a happy Thanksgiving. See ya.